So we are going to find the gradient of the train's descent. That train looks a little bit like a caterpillar to me, but regardless, we're going to find its gradient. Did anybody start that with rise over run? Yeah, that works, right? You do have to remember that that kind of slope, is it positive or negative?
It's negative.
It's negative, so if you use rise over run, just make sure you end up with a negative slope. To do it in a more mathematical way, you can also name the points here. So that point there is 0, 46. And this point here is 1,820, comma 0. And then you can use your slope formula. Rise over run is fine for testing as long as you show your method. So don't just like write it down, you have to show your method. Okay, so 0 minus 46, 1,820 minus 0. And I'm going to get a negative number. That's negative over positive, 46 over. And then I want to simplify that fraction. So you can do that on your calculator. You can divide it and do math frac. Okay, so negative 46 divided by 1,820. And then math and fraction. So it didn't simplify that much. It really just divided the numerator and denominator by 2. Okay, and then you're going to find the equation of the train line. Thinking about this, I might decide I want to have the one that has an x of 0, because then I can multiply my fraction times 0. So, oh, actually, we know what our b is, right? Yeah, our b is what number, guys? 46. So this is your y-intercept. So that is your, well, we used to call it b, now we call it c, which is your c. So if we're using y equals mx plus c, then we can have y is equal to negative 23 over 910 x plus 46. Any questions on our caterpillar train? I see a few people writing, so I'll give you a second. Okay, so relations and functions. Relation is the more general term. A relation between a variable x and y is any set of points x, y in the plane. So they don't even have to have like a rule to them. They can still be a relation if they're any set of points in that xy plane. And we say that those points connect the two variables, so the connection between x and y. A function is a special kind of relation. A function is a relation in which no two different ordered pairs have the same x coordinate in the first component. Now notice they said two different. Sometimes they give you the same point twice, right? Like 2, 5, 2, 5. That's not a problem because it's just the same point. So there's an algebraic test for a function, which is suppose a relation is given as an equation. If you substitute x and you can only get one value of y out, then the relation is a function. Geometric test is the vertical line test. So if your vertical line crosses the graph more than once, that would not be a function. If it crosses the graph only one time, then it is a function. And those two tests are actually doing the same exact thing. One's just working algebraically and one is working geometrically. Any questions before we turn the page? Okay, let's move on. So let's do a vertical line test real quick. Just a note about these graphs, the origin is marked with a circle. That is not a part of the graph, it's just a part of the axes. So ignore it, don't worry about that. Do a quick vertical line test to decide which ones are and which ones are not functions. All right, so looking at the vertical line, this one crosses once, that's yes. This one crosses once, yes. And this one, if I drew it right here at the vertex, it would cross once. But if there's anywhere you can draw it that crosses twice, that's a no. And just connecting that to the algebraic reasoning, this indicates that there is an x value with two different y values. There are 2 points that have the same x and different y's. Okay. When you're reading a graph, it says if it has an open circle, this point is not included. And that's why I thought this graphing scheme was kind of confusing, because you see this open circle here, but that's just part of the axes. That is not part of the graph. If the graph has a small filled-in circle, it is included, and an arrow, of course, means it just keeps going. So we're just going to remind you a few things about function notation next. Remember that f of x is a value of y for a given value of x. So f of x is essentially a y value, but by putting it as f of x, you can tell me it's the y for a certain x. So this means find the y when your x is 5. Okay? I'm going to write that down. Find y when x is 5. So you substitute in, that's the way you do it. You do 2 times 5 squared minus 3 times 5. $50 minus 15, so I'm getting 35. All right, go ahead and find f of negative 4. Yeah, you can put the whole thing in the calculator. All right, sometimes we substitute not in a number but an expression, and it looks tricky. It's the same exact idea. I mean, you just have to wrap your mind around the fact that you are putting in an expression instead of a number. So I'm going to substitute negative x for all the x's. I have 5 minus negative x minus negative x squared. This is something we do to test if something is an even function. An even function is symmetric to the y-axis, and for an even function, f of x is exactly the same as f of negative x. So if we get back the exact same thing, it would tell us it's an even function. That's not what I expect from this one, though. And we're not learning about even and odd, but it's just kind of nice to make a connection. So here I have 5 plus x, and then minus, but when I square a negative x, what do I get? Positive x squared. So I had the opposite of this term, but I had the same as this term. I also had the same as this term. So it's neither opposite nor the same, but it is 5 plus x minus x squared. And actually, we can write in front of it f of negative x equals. Okay, I'm going to help you set up the next one, and then I want you to see if you can simplify it. I need some space. So here we go. F of x plus 2 equals 5 minus x plus 2 minus the square of x plus 2. Okay, take a minute for that. All right. I'll distribute the minus here. But I'm not going to distribute this one yet because I want to see what's happening with my x plus 2 and x plus 2. I can combine my 5 minus 2. But I'm still not distributing this minus yet because I just want to see what I'm going to get out of all this. So x squared and a 2x. 2x and 4. So I did x times x, x squared, x times 2 is 2x, 2 times x is 2x, and 2 times 2 is 4. And I'm recording this, so if you want to hear it later, you can. It'll be linked on the Schoology page. Okay, so now I think I'll combine these like terms before I distribute that negative. So I'm going to bring everything down. Two x and 2x made 4x. Now I can distribute the negative. Lots of negative in this. And now I'm going to bring down what I found again. I found f of x plus 2. And I'm going to put this in standard form with the x squared first, negative x squared. Combining my negative x and my negative 4x to make negative 5x. And my 3 minus 4 to make a negative 1. Okay, I think that's right. You guys good with that? No. It's a lot to process, but I will post this so you can watch that again at home if you need. All right, the next one is interesting because it has f of x minus 1, and then it has minus 5 at the end. That minus 5 at the end just means whatever you get from your answer, you just subtract 5 from it at the end. I'm running out of space, so I'm going to grab a piece of paper. If you are also running out of space, feel free to work on a separate piece of paper. Okay, so I'm going to do part C here. Okay, so what I'm going to do is put the x minus 1 for the x, 5 minus x minus 1 minus x minus 1 squared. And then it says to put a minus 5 at the end. You just subtract a 5 at the end. So I substituted x minus 1 for all the x's, and then it just says, and then subtract 5 at the end. That's all. Okay. All right, I have a 5 and a minus 5, so I can just get rid of those. I don't need those. 5 and a minus 5, that makes 0. This negative can distribute, so I have negative x plus 1. And then I'm going to do exactly the same thing I did before. Bring down my minus and write my x minus 1 squared as x minus 1 times x minus 1. And then distribute. X times x times negative 1, negative 1 times x. And negative 1 times negative 1 is a positive 1. Combine these two like terms. Negative x plus 1 minus x squared minus 2x plus 1. Distribute the minus. And then finally combine like terms. So I have a plus 1 and a minus 1 that cancel out. My leading term should be the negative x squared. Negative 1x and positive 2x make a plus x. Next page. All right, please show me you are ready. All right. The blank of a relation is the set of values which the variable on the horizontal axis can take. This variable is usually x. So the set of x values is called the what? The domain. Good. The blank of a relation is a set of values which the variable on the vertical axis can take. This variable is usually y. That would be the range. All right. So to fully describe functions, we need both a rule and a domain. And what they mean there is that sometimes for functions, you can't just put any number in for x. For example, if it's a square root function, you can't take the square root of what kind of number? Negative, right. You can't do the square root of a negative number. So for some functions, we have to tell what the limits on the domain are. Okay? You might see them in set notation. You might see them in bracket notation. Usually they won't list it as a number line graph, but sometimes they will ask you to express it as a number line graph. And then this, of course, is what it would mean. I expect that you've seen set notation before. You may not have seen bracket notation, but it looks a lot like interval notation that you have seen. Number line graph you've seen before, and then the meaning. All right, so for these graphs here, remember that this is just part of the axes. That's not a hole in the graph. You can see it more clearly here. It's not a hole in the graph. It's just part of the axes. So we're going to try to do the domain and range. I'll do the first one with you, and then you'll try the second one. So I'm going to put domain and range. And actually, we're going to use interval notation, which is not actually up there. Interval notation, I hope, is the one you're most familiar with, and that's the one we're going to use, okay? Domain, on the left side, it seems to be going all the way to the left, so your domain starts where? Yes. Okay, in interval notation, remember, which is not listed up here, interval notation, we use a parentheses to indicate a number that is not included. Why is negative infinity not included? It never stops. You can't get to negative infinity. You can only head towards it. All right, so on the left side is at negative infinity. We continue reading across the graph until we get to the right side, and we need the last x value on the graph. What's the last x value on the graph? It is 8. You see that? When we get to this point here, the x value is 8, so it stops at 8. To show that we're including the number 8, we're going to do a square bracket. Now for the range, you want from the bottom to the top. One of the most common mistakes for domain and range is that people put the numbers in the wrong order. And a really easy rule to help you remember that is always the smallest number first and then the largest number. If you don't have smallest first and then largest, you did something wrong. You got to try it again. Okay? So on the bottom, you want your smallest y value, which is what number? -2. To include it, we'll put a square bracket. And it goes up, it goes down again, it goes up, and it keeps going up to what? Infinity, good. And remember, we can't get to positive infinity either, so we're going to put a parentheses on it. So take a minute and do part B and compare with your neighbor. All right, I saw a lot of good work. Your domain from the left to the right. On this side, negative infinity. On this side, positive infinity. Make sure you had parentheses. I saw some good work on that one. Range. Bottom to the top. So on the bottom, you had a y value of -1. And it kept going up to positive infinity. Any questions on that one? Yes. Are you going to use the graph? Okay, next page. All right. Graphing functions is one way. I'm going to ask you guys to quiet down because this is a little bit different. Graphing functions is one way to know what the domain and range is. And actually having an idea of what a graph might look like could definitely help you think about your domain and range. Does anybody know what the shape is of a square root graph? Kind of like a rainbow, half of a rainbow, right? It like starts at 0 and it goes like this. It's basically half of a sideways parabola. Square roots are inverses of quadratics, and so if you took that parabola and turned it on its side, it would be your inverse, except what's the problem with turning the parabola on its side? It's not a function, right? So that's why it's only that top half. All right, so for the square root function, you guys told me we can't do the square root of a negative number, right? Can we do the square root of 0? 0, right? Square root of 0 is 0. So this x minus 5, the part underneath, has to be greater or equal than 0. It can't be less than 0. So x minus 5 must be, okay, I want to remind you here that we're not solving the equation. We're talking about what x can be. It says x minus 5 must be greater than or equal to 0. I'm not solving, I'm finding the domain. So I'm going to add 5. And x must be greater than or equal to 5. So let's think about how that would look in interval notation. For your domain, the first number in the domain is what number?
5.
Sophia says 5. Anybody want to agree with that? First number is 5? Yeah? Thanks, Torian. First number is 5. Is there any limit on how big it can be? No. So we'll go all the way up to what? Infinity. All right, but what about the range? Any suggestions on to how we could find the range? I see one hand already. I'm wondering if anybody else wants to raise their hand for an idea. I'll take good ideas, I'll take bad ideas, I'll take crazy ideas. Bless you. All right, Sophia, what do you want to give us?
Well, if x minus 5 has to be like greater than 0, then it can be, it like has to be at least 0.
Okay, so she is suggesting if the x minus 5 itself has to be greater than or equal to 0, then x has to be at least 0. Good point. So I can connect to that with putting this 5 back into the function, kind of what she was talking about. If I substitute that 5 in, I'm going to get the square root of 0. So that means 0 is my first number in my range. And just like there's no limit for the domain, there would be no limit for the range. All right, in B, it's a different rule. You are allowed to divide by a negative number, right? We do that all the time. 1 divided by a negative number, we can do that. But what number are you not allowed to divide by? 0, okay? So there's only one number your denominator can't equal, and that is 0. So x minus 5 in this case cannot equal 0. So that means x can't equal what number? 5. X can be any number in the world except for 5. All right. So for your domain, we want to say every number except for 5. So what we're going to do is we're going to start negative infinity and get up to 5, but not include it. We're going to use parentheses to say not including 5. So negative infinity all the way up to 5. Leave it out. And then right after that, we're going to start right after 5 and go to infinity. So notice how convenient these parentheses are. They're saying you're going to get as close as possible to 5 without getting to 5. Skip over 5. And then you're going to go all the way to infinity. The range is trickier because if I substitute 5 in, I get 1 over 0. And what is that? No, because we're not allowed to do it, right? 1 over 0 is like, it's not allowed. It's just not a number. So if you have a graphical understanding of the function 1 over x, you'll remember that it has horizontal and vertical asymptotes on the axes, and then it has a branch on each side. So if you have a graphical understanding of that, you might know that it is at 0, even though 1 over 0 doesn't equal 0. If you don't have that graphical understanding and you're allowed a graphing calculator, you could look at a graphing calculator to see where those asymptotes are, and see where you might be leaving a number out. Without that, you could analyze this by looking at both sides of what happens when we put in a 5. So think about what happens when we put in 4, okay? So f of 4 is 1 over 4 minus 5, which is 1 over negative 1, which is negative 1. What happens when we put in 6? F of 6, 1 over 6 minus 5, which is 1 over 1, which is 1. All right, so if I wasn't familiar with the shape of the function, if I wasn't allowed a graphing calculator, it seems a reasonable guess to think that if f of 4 is negative 1 and f of 6 is 1, then f of 5 would be right there in the middle, right? At 0. And it does turn out 0 is the number that we have to leave out of the range. So we'll leave that out the same way. Negative infinity to 0 and 0 to infinity. All right, so take a moment now and try C. You should be able to find the answer to C by putting together your thoughts from A and B. Notice the connections between those. Okay, so in this one, it is both a square root and a denominator. So greater than or equal to 0, but also not equal to 0. So just what? Just greater than, yeah. So x minus 5 is just greater than 0 because we know it has to be positive, but because it's a denominator, it also can't be 0. So we'll add the 5, like that. And let's see what else. X is greater than 5. So here, instead of including the 5, it's just going to have a parentheses. And same thing here. For the range, since we didn't include the 5, we don't include the 0. And you're going to go to infinity. On your calculator, press y equals and enter the first function. Okay, so I typed in the one from the worksheet right here. And then I'm going to press graph. And my graph, I can see it, but if you can't see it, then you'll go to zoom and choose 6, which is standard. Okay? Can you see it? It looks kind of like a tilty parabola. Yeah. Okay. So to know the domain and range of this function, we want to find out what that top point is. I can actually tell what the domain is right now. What do you guys think the domain is? It's negative infinity to positive infinity for your domain. Okay, for the range, we have to find the maximum. I'm going to make this note here. Find the maximum. Okay, the way we do that is we do second and then trace. Second, trace. You'll see the command for maximum, that's 4. Then, I can't really write this part down, so watch me if you're not sure what to do. It asks for a left boundary. It wants the cursor to be to the left of the maximum. Right now I am to the left of the maximum, so I'm going to press enter. Okay. Then it asks you to go to the right of the maximum, so you use the right arrow until you're to the right of the maximum. And you press enter. When it asks you to guess, it just wants you to move close to the maximum and press enter again. And it gives us the point. Which of those numbers will we be using in the range, the x or the y? The y. Raise your hand if you would like me to show the steps again for finding the maximum. Okay, very good. Ready? Do second, trace, and then maximum is choice 4. It asks you to go to the left of the maximum, so you have to make sure your cursor is to the left of that highest point, and then you press enter once. It asks you to go to the right of the maximum, so you use your right cursor to go to the right, and you press enter again. Then it asks you to guess, so you move towards the top of it, and you press enter one more time. So our range is going to start down at negative infinity, and it's going to go all the way up to that maximum. Let's do 3 sig figs, so we'll write negative 5.81. I have x squared, so here's my x button, here's my squared, minus 1 over x. Ooh, that's fun. Mm-hmm. All right, so let's look at that together. Now, do you see any horizontal asymptotes that might indicate that we have to leave out a y value? No. And if you look, even though this left branch seems to have a minimum point, the right branch looks like it's going to continue all the way down. Because of the asymptote, it's getting infinitely closer to it, but it keeps going down. So we do look like we have negative infinity here, all the way up to positive infinity here. It does not matter that this piece has a minimum point because this piece has us covered. So that's going to be our range. Oops, what am I even writing? Negative infinity, infinity. And let me minimize this so you can see. There you go. Okay. These are longish notes today. So we are going to finish the notes, which means that we might not do the next exit ticket till next class. And next class will also be a work day, okay? Yes? Yeah, you have to start your pass. All right. If a model follows a specific rule, that model is exact. We can use our linear model to find the exact data. In many situations, the connection between the variables is not exact. If we plot a set of data points, we may see a linear trend, which means it looks close to a line, which suggests a linear model would be a good approximation of the situation. Okay, so we have a graph here that's showing C dollars, which is the cost of buying X bottles of juice. So to find the model, they're asking us to find the equation. So to find the equation, we need, yes. To find the equation, what do we need? Slope, which is also the gradient. And what else? The y-intercept, yeah. Okay, so our gradient, you can use your slope formula, your gradient formula, or we can just do this. Actually, I want to use the ones that land on numbers, so I'm going to do this one, and then this one. Okay, So the change in y is going up how many? 5, and then the change in x is going over how many? 2. So the gradient is 5 over 2, which as a decimal is 2.5. What does that mean? What is 2.5? It's the change of cost for each what? Bottle. How much does the juice cost? The juice costs $2.50. Good. So $2.50 for 1 bottle of juice. Okay. And then the y-intercept is what number? 0. So let's see if you can write that equation real quick. All right, so we said our y-intercept, which is our c, that was 0. And so our equation would be y equals 5/2 x plus 0, which simplifies to y equals 5/2 x. Would you say that model is exact or approximate? Go ahead. You need to go? No? Go. Put your pass in though. Okay. It's exact, yeah. When you go to the store, they're not going to ask you for approximately $7.50. They're going to say it is exactly $7.50. So it's an exact model. Can the model be used to find the exact cost of 12 bottles of juice? Yes, it can. Go ahead and find that. Oh, you know what, guys? I should have used the right letters on this. They use C. C equals 5/2 x. All right, you guys getting $30? Okay. All right, when you're ready, you can turn the page. All right, piecewise models. A piecewise linear model is a model made of several straight line segments. All right, here's our problem. The cost of printing invitations depends on the number of invitations printed, as shown in this piecewise linear model. Find the gradient of the following and interpret your answer. So if you've ever had to order invitations for an event like a quince or a sweet 16, then you may have had to print invitations, and they have a lower charge per card when you order more. So if you only want like 20, then you might have to pay like $5 a card. But if you want like 100, then maybe you only have to pay $1 a card. So same with like printing t-shirts, if you're like sell t-shirts for an event or something. So it says the cost of printing invitations depends on the number of invitations printed as shown in this piecewise linear model. Find the gradient of the following and interpret your answer. So that's a typical IB thing. When they say interpret your answer, they mean, what does this number mean? So go ahead and do that. Find the gradient of each part and interpret your answer. All right, let's see how you did here. So for the first one, for AB, I could do change in y is 50 and change in x is 100. Which gives me 0.5, but if I'm talking about money, I might want to call that 0.50. Now, I just made it the number, but if it was a fraction, that 0.50 would be over what number? What number can you divide by and not change something? 1. So it would be 0.50 over 1. That means that the cost is 50 cents for one what? Invitation. All right, let's look at BC. The change in Y is 30, and the change in X is 100 to 200, so 100, right? Did you guys get 30 over 100?
Yeah.
Okay. 30 over 100 is 0.30. Could be 0.30 over 1, so that means that it's 30 cents for one invitation. So buying more, you get a lower price per invitation. So when does it switch over between the low price and the high price? More than 50. When does it, look at the graph. Oh yeah, $50, good. And how many invitations? 100. So it switches over between $50 and 100 invitations. This right here is the important point. So if we're doing 60 invitations, do we pay the high price or the low price? 60 invitations. It's the higher price, right? Because it's not 100 invitations yet. This one is the higher price, and that's the lower price. So we're going to pay the higher price because we didn't get to 100 invitations yet. And so it's going to be 50 cents per invitation times 60. So it should be $30. $74. Look at your graph. Is that going to be in the higher price or the lower price? In the lower price, right? Because it's up here. $74 is going to give us more than 100 invitations. So we're going to use the lower price. $74 is the price for 30 cents times X invitations. And divide by 30 cents. All right, so that's not my final answer, obviously. Can you get 0.66 invitations? Do you have enough money for 247 invitations? No. So you can print how many? 246. So normally, like in math world, this would round to 247. But you have a limit on your money, so you can't spend more money than what you said. So I can buy 246 invitations. Okay, we did it.